This week in class, we're studying Ethernet, and we also have to study ARP. The question is, when do you need ARP, the Address Resolution Protocol? Well, you need ARP if you plan on communicating on an Ethernet LAN, because on an Ethernet LAN, to deliver messages from one device to another, it's done to the device's MAC address, and you have to discover those devices' MAC addresses. So in this scenario, A wants to communicate with B and send a message to B. And it says here, I want to send to PCB, but I do not have the PCB MAC address. So in computer A looks in its ARP cache. You can see here in the command line, ARP-A, and in the ARP table in PCA, there's no MAC address, IP address to MAC address mapping. In other words, if A wants to communicate to B, it not only needs to know its IP address, it needs to know its MAC address. You cannot communicate with a device on an Ethernet LAN without knowing their MAC address, because it's actually, the frame is actually delivered to the NIC's MAC address. So let's see what happens. So to solve this problem, PCA sends out an ARP request, and the ARP request says, who has the MAC address for 192.168.11.11? Tell 192.168.11.10. So tell A the MAC address of B, 11.11. Now this ARP request is broadcast out on the network at layer 2. Notice that the frames that are sent out are to all Fs. That's a layer 2 broadcast, It's an ARP request. So the packet goes over here to the router, it hits the switch and goes over here to PCB, and we'll see what happens here. So the router gets it and says, hey, this is not for me, I'm not 192.168.11.11, and discards the ARP request. PCB says, hey, this is for me, I have it, and it takes that ARP request. So in reply, PCB sends an ARP reply, and then PCA adds the MAC address to its ARP cache. Let's take a look at this. PCB says, here's my MAC address, puts its MAC address in the ARP reply, sends it back to PCA, and PCA will add that MAC address to its ARP cache. Now if we look at PCA's ARP cache down here, you can see that it now has an entry. 192.168.11.11 is at MAC address all Bs. So now A knows what to do, it knows how to reach 192.168.11.11, and now I can deliver an Ethernet frame to BBBBB, and it's able to send the frame over to host B. The ARP table has the entry in it, and it can communicate with B. Now let's see what happens when PCA wants to reach Cisco.com on the internet. So PCA now wants to communicate onto the internet and go to Cisco.com website. I want to go to Cisco.com, but I need the MAC address of the default gateway to get there. To get to an unknown network on the internet, you have to go through the default gateway, which means you need the MAC address of the default gateway. But in the ARP table, PCA does not know the MAC address of the gateway. It doesn't have an entry for that. So what's it going to do? It's going to send out another ARP request, and it's broadcast all Fs in the destination MAC address field, and basically says, who has the MAC address for 192.168.11.1, the default gateway? Tell me 192.168.11.10. So that goes out, and PCB ignores it this time because it's not addressed to it, but the router says, hey, this is addressed to me. They want the MAC address of 192.168.11.1. I have this. This is for me. And it returns its MAC address in an ARP reply to PCA. Once PCA has that, it's able to communicate and reach Cisco.com by way of the default gateway, where it delivers the frame to the default gateway. When it gets to the router can then move it on towards its destination. And that's the ARP process. Now, if we want to see this in action, all we have to do is open up Wireshark, and I'll run a packet capture on Wireshark on my Wi-Fi network. So there we go. I'm now capturing packets. And now what I'll do is I'll open up a command prompt with administrative privileges. And there's my command prompt. And the first thing I'll do is I'll run an ARP-D to delete my ARP cache. I'll run it again just to be sure. And now maybe I'll open up a web page and go to my website. Now I will stop Wireshark. And we can take a look in Wireshark at what we captured. So I'll put in an ARP filter. There's my ARP filter. And you can see right away, look at all these ARP broadcasts. Now, if I go back to my command prompt and check my IP address, you can see that my IP address is 8.165. The default gateway is 8.1. So if we look in here, we'll see if we find 8.165 and 8.1. Here's the last one right here. Who has 192.168.1? Tell 192.168.165. So this is my IP address, 8.165. I'm the sender IP address. Here's my MAC address, Intel NIC. And the target MAC address is all zeros because I don't know the router's MAC address. But I do know the router's IP address. So my goal is to find the MAC address from the IP address, and this is an ARP request. And you can see here, address resolution protocol request, and then the reply comes back, and this is an address resolution protocol reply. And now the sender's IP address is 8.1, which is my router. And you can see the sender's MAC address right here, and you can see that it's addressed to me. So there you have it, an ARP request and an ARP reply. And now if I go back into my command prompt and run an ARP-A to see all of my ARP cache, you'll see right away that there is the entry for 192.168.1, my router default gateway, and there is the MAC address. So I'm able to contact the gateway again with the MAC address, and that happens instantaneously because I'm pretty much online. So as soon as I deleted my ARP cache, it basically went out and did the ARP broadcast, the ARP request right away, and I was able to get that MAC address right away from the network.